Jai Shri Gurudev, Jai Shri Gurudev, good morning one and all. Yesterday we solved a problem, simple problem. Now today we solve one more problem related to chord beam. The problem number 2. Now read the problem. Compute the combined stresses at the inner and outer fibers in critical cross section of crane hook. The type of the machine element is given as a crane hook, which is required to lift a load up to 25 kilonewton. The load is given. The hook has trapezoidal cross section. Now the cross section of the hook is given, trapezoidal cross section with the parallel sides 60 mm and 30 mm. The distance between them is 90 mm. The inner radius of hook is 100 mm. The load line is this important. The load line is nearer to the inner surface of the hook by 25 mm than the center of curvature at the critical section. Now in the previous problem the load line is away from the center of curvature, is far away from the center of curvature, but here the load line is near the inner surface of the hook. Means the line of action of force, it lies between inner surface of the curvature and the center line of the curvature. From the center line of the curvature, it is how much? Is 25 mm towards the inner surface of the curvature or inner surface of the beam. What will be the stresses at the inner and outer fiber if the beam is treated as straight beam for the given load? Now first you consider the curved beam, then you consider straight beam, then determine the water stresses induced. Now based on this problem, now write that a crane hook. Now this is a crane hook. You can see the data handbook also. You can get this shape. Now what is the cross section of that crane hook? Is a trapezoidal cross section. The parallel sides are 60 and 30 mm, and distance between that is 90 mm. This is the inner surface. This is the outer surface. And is given the inner radius of the curved beam is 100 mm. This is the center line of curvature. And the load line, the line of action of force is given, right? The load line is nearer to the inner surface of the hook by 25 mm than the center of curvature at the critical section. The load line is in between the inner surface of the curved beam and the center line of curvature. How much distance here from the center of curvature is given? 25 mm. This is a load line. Usually there's in the crane hook, load carries here, the load acts vertically downward, right? Then draw the center. Then after that you determine the stresses induced in the curved beam. Consider the curved beam and also straight beam. Now then draw the centroidal axis and neutral axis, right? Then redraw the a trapezoidal cross section and with the notations. And here see the line that is L is the distance between the line of action of force and the centroidal axis of the cross section, right? Then after that, then write the given data. These are the given data. Our aim is to determine the stresses induced in the beam. First you consider the curved beam, then straight beam. Once you write the given data, what are the other data? These are other data. How to get other data, such as the the radius of the centroidal axis and radius of neutral axis and other things. How to get radius of centroidal axis? By referring table 2.7 for trapezoidal cross section. Now see that from the table 2.7, see that this is the trapezoidal cross section as it is. I taken that the notations H B B0 by 2 B0 by 2. This is inner fiber. At inner fiber always cross section is more, outer fiber cross section is the dimension is less. Here C is given from the outer fiber, nothing but is C is equal to C2. This is centroidal axis and H is given. From this, according to the sketch, write the one more type. The data B is how much is given from the given data. B is 30 mm. Then B0 by 2 plus B plus B0 by 2. Whole thing it is how much it is 60 mm. From this you calculate what is the value of B0. Then H is given. Then from the table 2.7 for the trapezoidal cross section, from that you get the, this is a formula you will get from the table for the trapezoidal cross section. Now substitute the value of B and B0, then you get the area. Then here you calculate area moment of inertia also, because you have to solve the consider the straight beam. That will consider the IA value also. If you solve only curved beams, don't consider this value. Next, then you go for determine C. C is the distance from the farthest point from the central axis. To the here is given outer fiber. Nothing but C is equal to this formula, that is C is equal to C2, that is 50 mm. After that, then you calculate C is equal to C2, you calculate it, then C1 you calculate from this formula. Then RC, as you know that the central axis, radius of central axis is RI plus C1, that is RC is equal to 140 mm. Now this you get RC value. Then how do you get RN value? By referring table 25.2 from volume 2 for trapezoidal cross section. This is the RN formula. Then 25.62. Now whatever the notations you use already see in this here, it is same as that in the table 25.2 for the trapezoidal cross section, BI, B0 and H, right? Now substitute that value of H, BI, B0, all these values, that's equation number 25.62. Then you get Rn value. Then how do you verify it? Rn is always less than Rc, right? Then calculate the remaining other dimensions, Ci, C0 and eccentricity. Now what is L? L is the distance between the line of action of force and the centroidal axis. Here what is the L here? L is nothing but this is the L. How do you get this? From RC minus 25 mm, that will get L value. Then you know the moment is equal to force into perpendicular distance. Now this is here is an eccentric load, right? Now this is a load acting here, the eccentric load. The load transfer this load to the centroidal axis. That case on the section is a tensile forces is acting, and apart from this a force into distance that produces what? Moment also, and that produces moment. And above the neutral axis, what about the fiber is subjected below the neutral? What are the fibers subjected due to this movement, due to the force that produces the movement? Above the neutral axis, fiber undergoes a compression. Below the neutral axis, fiber undergoes tension, right? Now an eccentric load F is applied on the crane hook. From this you will get a two type of, due to a two type of stress are developed. One is direct stress, other one is bending stress. Direct stress you will get due to F, and bending stress due to the force into distance. Now after this, now we'll go for determine what is the direct stress. As you know that direct stress is equal to F by A. Substitute will get this value. This is a tensile in nature. Bending stress, you know the inner fiber, bending stress inner fiber, you know the from the data handbook 25.55. Again bending stress inner fibers are is tensile in nature, and substitute value will get this value. This also in tensile. At outer fiber, bending stress outer fiber is subject to what here? Negative sign you get because of compressive nature. Then substitute the value, you will get this value. Now we know the combined stress formula is the sum of direct stress and bending stress. Now where is the maximum tensile stress is occurred? Maximum tensile stress occurred at inner fiber. Now substitute the value, we'll get this is the value. This is tensile in nature. Maximum compressors is occurred at outer fiber. Then this is the substitute is, we consider only plus and then the compressive stress and negative nature. Substitute here, we'll get this value. This is again negative sign, will get compressive nature. The maximum shear stress actually is not given. Better we calculate this value is half of the normal stress maximum. Normal stress, maximum normal stress. Where you get the maximum stress here at the inner fiber. Next, so these are stresses you'll get at the consider as a curved beam. If you consider as a straight beam, again redraw the trapezoidal cross section. As you know, the straight beam, neutral axis and central axis and neutral axis are coincide. Now from the central axis, what is the distance at inner fiber C1 at outer fiber C2? How do we calculate C1 and C2? Right? From the table 25 point, from the table 2.7. The bending stress in a straight beam will get from this equation. You already know, familiar with this formula. Sigma B is going to be by I into Y. At inner fiber, put Y is equal to C1, that is 40 mm, already calculated. Substitute, okay, this is the value, this is tensile nature. At outer fiber, put Y is equal to C2, 50 mm, that is or Y is equal to, its substitute is minus C2 actually, negative Y directions, or will take C2, then yeah, minus C2, then we'll get negative compressive nature. Now we'll get this value, right? Now combined stress at inner fiber, the same formula what we use, substitute, you'll get this tensile. Combined stress outer fiber, this is the formula, substitute, you'll get this value, compressive nature. If you want, you can draw the stress distribution both in curved beams and straight beam. Thank you for watching this video.